Okay, so here's a new problem. So I have a grid again. Perfect job of erasing. But instead of the whole grid, I can only, I've got almost like it's a triangle. And so I'm trying to walk from here to here, but I only have this triangle to live on. So previously, I think this is a 4x4. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Yeah, sorry. 1, 2, 3, 4. Yeah. So this in our previous method, this would have been 8 choose 4, which is, let's see, 8, 7, 6, 5 over 4, 3, 2, 1. 1, 3, 2, 1 kills the 6, and 8. So I got 70.
Yep.
So previously, I would have had 70 different paths. What's your guess about the number? What happens to the number of paths in this grid?
Well, since logically, half of the paths might involve this side of the grid, so it might be chopped in half.
Well, I guess you can also say that because half the paths from here are going to start up because it's a 4x4 grid, and half of them are going to start over, but you can't start up, so you have to start by going over.
Okay.
So I
It's
think
gonna
half of
cut
them.
away half the paths, but you're gonna also lose more from going up twice here, up 3 times here.
Yeah.
Yeah.
So
So with
probably it's
the
gonna be
grid
less
counting way, I think that's the easier way here.
All right. So we think it might be 35. Not sure. Do you think? But you then were saying you think it might be less than 35.
It's probably less because you lose the path, not only the half that go here, but you lose the paths that go over, up, and then up more than once here,
Yeah.
more than twice here, not more than 3 times there.
Okay. All right.
So-
Well, let's see what we get.
2 ways, do here, 3 ways. And then there's no other point that goes to here, so this is 3 as well.
Oh. What was there 2 ways to get to this point?
Well, there's not. Just one way to get there.
Why did you think there were 2?
Well, there's normally 2. If there's a point here, then it's 2, but there's not a point here.
Okay. Why is there only 1?
Because the only way you can get to this point is via that point.
Okay.
So that means that this changes. This is 2, and that's 2. And then this one is 3. This one's 4. And then this one is 5. 9. This one's 5. This is 14. And this is 14.
So it's less than 35.
It's quite a bit less than 35.
Yeah. So initially we thought it'd probably be cut in half.
But it's less than that.
Yeah. So why? Why is it less than half?
Well, so you have some paths start going on the full grid, some paths start going up and don't ever go on this side of the grid that's full. And some that do the opposite. They come on, start going right, and they don't touch this side of the grid.
Okay.
But then there are some that say go up and then go right and touch both. And those are going to be excluded along with the ones that start up and go this side.
All right.
Okay, I guess there's 5 cases, or four cases here that we omit. We omit the case that starts up. We omit the case that starts over, up, up, and then over. There's a bunch of ways to get to here, but there's the case that ends up here and goes up, and the case that ends up here and goes up.
Yeah. Yeah. So these numbers on the diagonal here, 1, 1, 2, 5, 14. The next one's 42. These are called the Catalan numbers, and they come up in surprising ways, and they're a little bit more difficult to understand, especially than you might think they would be, given how simple it was to understand prior. numbers as binomial numbers. So they turn out to be related, but the relationship isn't clear. But so here, this is an example of where the grid counting method is really helpful to you, unless. Well, you know what? Even if you had something, this triangular sort of array that was 1 over 10 and up 10, it's still not too. The numbers are going to get big, but it's still not.
Not too hard to see.
It's not. It's just you could probably write a computer program that would do it very easily. And this also tells you how to solve kind of odd-shaped grids when you can only go left and right. Okay.
Nice.
All right. So let's go to the next one.